Okay, the third question is another tabular problem. It tells you there's a function h having derivatives of all orders for x is greater than 0. All that means is that the first derivative exists, second derivative, third derivative, fourth derivative, etc. It gives you a certain values for h and the first four derivatives. It says the function h and these four derivatives are increasing. Think about what this means. They tell you that h is increasing, but it also tells you that the derivatives are increasing. So if h prime is increasing, that is also really telling you that h double prime is greater than 0. Okay? So the first question is this Taylor polynomial question. Write the first degree Taylor polynomial. So the first degree about x equals 2, so let's think about our general formula. So if I want to create the first degree polynomial, your first value should be h of 2, then your second term is h prime of 2 times x minus 2. I'm going to get my values from the table. H of 2 is 80, h prime of 2 is 128, x minus 2. It is 2 points for the correct polynomial with the correct numbers plugged in. Then it says to approximate h of 1.9. So all I'm going to do is plug in 1.9 for x right here. You can punch it out on your calculator. So h of 1.9 is approximately 67.2. That's your next point. Then they ask, is this approximation greater than or less than? Notice that the polynomial you came up with is a tangent line. Anytime they ask you if a line is an under approximation, over approximation, then the function, you always need to be thinking about the second derivative. I know that the approximation from the polynomial is less than the actual value because h prime is increasing from 1 to 3. Because h prime increasing really implies that h double prime is greater than 0, which means it's concave up, so the tangent line is below. But this is the justification you need to show. It is 1 point for your answer with the reasoning. So part A is a 4-point question. Part B, same thing, write the third degree. So let's think about how we're going to create the third degree. The third degree is h of 2 plus h prime of 2 times x minus 2 plus the second derivative of 2 times x minus 2 squared over 2 factorial plus the third derivative of 2 times x minus 2 cubed over 3 factorial. This is my general formula. You need to find the values and actually plug it in. So I'm going to get all the values from the table. This is 80. This is 128. This is 488 over 3. This is 448 over 3. Now all I'm doing is plugging into here. It is 2 points for the entire polynomial, minus 1 for each error that you have. And then now they ask you, using this, go ahead and plug in 1.9 wherever you see the x and punch it out on your calculator. And I get 67.988, which is the approximation. This is a 3-point question here. Part C. Oops. Use the Lagrange error bound to show that the third degree polynomial about x equals 2 approximates the actual value with an error less than this. So they want you to use the Lagrange error bound. So we learned that the error bound comes from the next term over. So the error bound associated with the third degree is going to come from the term that has the fourth derivative in it. So this is my general formula that I need to come up with. And when we talk about error bound, we only look at absolute value. This value is given, and I know that this is the biggest value possible because it tells you in the original stem that these derivatives are increasing. So this is the biggest value this could possibly take on. And then x is whatever x value they want you to approximate, which is 1.9. C is the value you're centered at, and then 4 factorial. You have a calculator, I can punch this out, and if you do that, this is what I get, and you just check, yes, this is a number less than this value here. It is a point for all of this, using this value correctly, a point for your check that this is less than the 3 times 10 to the negative 4. 2-point question.